Hey everyone, welcome to ALevel Mechanics with Daniel Dallas. This is a revision and I consider vertical motion under the force of gravity. It's all about basically point particles, different objects that you can consider as point mass, right? The mass is concentrated as in the point, and so that any rotational effects can be neglected, so we consider only translational motion. All right, and we gonna go through harder questions, EP and P level, also challenging questions. All right, so here is a quick reminder from previous videos where I discuss all three main formulas that you can use and that's very applicable to in order to cope with this sort of problems for the vertical motion topics. Okay, and if you're not sure why each formula looks like, you can see right now on the screen, so check out my previous video. And also, if you're wondering about physics that lies behind the scene, it's also gonna be useful to watch. All right, so bear in mind all those formula. Here is the problem one. Okay, EP level. Just read carefully, grab your pens, grab your notes, and try to do by your own as always. Okay, so what's happening here? Particle P is run vertically upwards from point O with speed u meter second to the negative 1, so means it is the same as if you use the index rule, right? You just flip over and you'll get meters per second. So meters per second, that's an equivalent way of writing. Okay, so 2 seconds later it still was moving upwards with a speed equals to a quarter of u. Okay, find the value of u. So what scenario we have in the first A part? So actually we have the following. We have point O. It might be the point somewhere on the ground, on the surface, or it might be any point in the air. It doesn't matter. So in this case, we can say that initial velocity was directed upwards, and the speed, it means the absolute value, was u. Okay, somewhere after 2 seconds passed, okay, it reached this point, for example, and here it had velocity quarter of u. Okay, so that's why I put small vector here, and I mark this as 1/4 of u right now, and still upwards, right? It was moving upwards according to the words. So we need to figure out the value of u to 2 decimal places. All right, so let's do this. So what we're gonna do, we're going to apply the formula that expresses the final velocity through the original one, okay? And due to the fact that gravity force and hence acceleration directed downwards, so we can say that it's going to be u minus gt. Okay, so instead of v as the final velocity and final value of the speed, we can use the quarter of u according to initial statement. So that means right now, if we plug this into the formula, we'll get u minus gt. All right, so we given the time, which is 2 seconds. We have g equals to 10, so from here we can recalculate u. So first of all, express u, so transfer to let's split the variables. Gt, actually it's not, the variable is known in this case, but u we can combine with u on the right side, and it's going to be 3/4 of u will be equal to gt, from where we can express that u finally is going to be 4 gt over 3. If you're really confused about re-expressing or formula rearrangements, so I encourage you to calculate immediately, just plug all the values in, and that will be much easier for you. But for those who want to struggle or who wants to get the final expression and only then plug the values, here is the final expression so you can reconcile. All right, and here we going to plug 4 times 10 times 2 is going to be 80 here on the very top, and over 3. That's going to be the value of the velocity. So it's around 26 point. Yes, actually, let's calculate quick. So 80 over 3, 26.67 meter per second. Okay, so that's scenario, and that's basically the picture that you can have for question A. So find the time interval from the instant P leaves O to the instant it returns to O back again. All right, how it looks like? Let's put drawings first of all. Let's say here is the point O. It starts from here with initial velocity as we defined before. Okay, that's going to be initial velocity that we found, and after reaching the maximum height where velocity is 0 or speed is 0, it goes backwards. Obviously, due to the fact there is no air resistance, it comes back again to point O with the same velocity, but directed downwards. So that means you can say in terms of vector velocity is going to be negative u, obviously, but the value is going to be the same. If you're not sure, you can derive this fact by your own, okay? But I will use this fact. So, which formula to use in order to find time interval? Of course, I think there is no way to use, let me see. Actually, there is the way to use formula for final speed, yes. So final speed is going to be equal minus u because it's downwards, right? As you remember, we stick to the rule that we direct, let's say, y-axis or x-axis, doesn't matter. So, and we project everything on that axis. And we can use initial velocity, which is positive, and minus gt according to, of course, according to the rule. From where you can establish time, so you'll get 2u equals gt, from where time traveled to the maximum height and the way back is going to be equal to u over g. Okay, here is an alternate way using displacement, okay? So this is way 1, which is pretty straightforward, but I'll show you way 2 because it's always applicable here. So I can consider the total displacement, okay? Let's consider total displacement. It's obviously 0 because it goes upward and the way back. And total displacement, as you remember, displacement is a vector connecting the starting point and the ending point, is going to be 0. And according to the formula, it's going to be equal to ut minus gt squared over 2. Okay, so hence you need to solve this equation that ut minus gt squared over 2 equals to 0. So you can factorize t, and in the brackets you'll get u minus dt over 2. Okay, and because the result is 0, there are two options. T1 is going to be equal to 0. That's the starting instance of time or moment of time. So T1 equals 0 is basically when it starts moving upwards, okay? And from the second brackets can be also equal to 0. So that means the second time instance is going to be equal to u over g. And if you compare with the way 1, you'll get the same, absolutely the same expression, okay? So that's why, as you can see here, you can use several ways. If you don't know which way to use, just try to put several equations by just step by step. For example, you wrote this, you understand that you can find this, can find time, so just don't do anything except for solving this equation. If it's not possible, try to write down another equation. It might be helpful, okay? And I just, in many cases, I encourage to write several equations in order, if you don't know what to do from the very beginning, just try to express, let's say, final velocity, try to express displacement and see what you can do here, okay? Is it possible to find it or it's not possible? So, okay, and let's calculate time. Finally, time is going to be equal to U over G. And if you plug the values, so just times 2 and over 10, we'll get 5.33 recurring. So to 2 decimal place, that's going to be eligible answer. All right. Okay, so well done. That's the value for the speed to 2 decimal place, and this is the value for time travel to the maximum height, max height, and the way back. Okay, hope you got it. Let's move to the next problem.